Hi guys, so today we are going to solve some questions of rate and work. Let's start with the first one. A fort of 80 men has food for 45 days. 15 days later, reinforcements arrive, leaving the number of days the food would last to 20 days. What was the strength of the reinforcement? Over here, we can say that total food is equal to 80 into 45 days. So 80 after 15 days, the food left would be 80 into 30. So we'll subtract 15 from 45. This is equal to 80 plus x. Now x are the number of people arriving into 20 days because they have said that the food would last only for 20 days. So this is the equation that is formed. Now after solving this equation, we'll get the value of x as 40 men. Hence, the strength of reinforcement is equal. Moving to the next question. X can do a piece of work in 10 days working alone, Y can do it in 15 days working alone, and Z can do it in 25 days working alone. How many days will it take to complete the work if all three of them work together? We will follow the steps. So, first we'll take LCM to find the total work. So, LCM of 10, 15, and 25 is 150. Now, then we'll find out the individual efficiency. So, efficiency of X is 15, Y is 10, Z is 6. They're working together, hence their efficiencies would be added. So total efficiency is 31. And now time taken is equal to total work upon efficiency, that is 150 upon 31. This is equal to 426 by 13, 31 days. So option 1 is the correct answer. Tap A can fill a vessel in 12 hours, tap B can fill it in 18 hours, while a drain pipe C can empty it in 24 hours. How much time will it take to fill the vessel if all the three are operating simultaneously? Now, over here, there's a drain pipe. So always take drain as negative efficiency. The steps would remain same. First, we'll take LCM, that is 72. Now we are going to find the individual efficiency. The efficiency of A is 6, B is 4, and C is -3. It's a drain pipe, hence we have to take negative efficiency. They all are working together, hence we'll add all of them. So 6 plus 4, 10. 10 minus 3 is 7. Hence the combined efficiency is 7. Time taken is 72 upon 7 hours. That is 10, 2 by 7. Option 3 is the answer. Next question says, X can do a piece of work in 10 days working alone. Y can do it in 15 days. All three of them start on first day. After working for 2 days, X quits. After another 3 days, even Y quits. In how many days will the job get completed? First, we'll take the LCM. Now, let's try to figure out the number of days. Now, we don't know the total number of days taken. So, let us assume the total number of days taken is n. Now, Z will be working for all the days. Hence, Z will work for n days. X quits after 2 days. So, I'll write 2. and y quits after another 3 days. That is, y quits after a total of 5 days. So I'll write 5 days beside y. And now I'll solve this. So work done would be 2 into 15 plus 5 into 10 plus n into 6 is equal to 150 units. After solving this, we'll find out the value of n. So n is equal to 70 by 6, that is 11, 2 by 3 days. Moving to the next question. X can do a piece of work in 15 days working alone. Y can do it in 25 days working alone. How many days will it take to complete the work if two of them? We'll find out the LCM to get the total work, and then we'll find out the individual efficiencies. Now there are two cases over here. First case is if X works on day 1. So if X works on day 1, X will complete 5 units. On day 2, Y will work because they are working alternatively. So Y will complete 3 units. This means they are completing 8 units in 2 days. Now we have to find out in how many days will they complete 75 units. Don't cross multiply because cross multiplying will not give us the answer. As over here, there are 2 days is equal to 8 units. We don't have 1 day. If 1 day is equal to 8 units, then we would have done this by using cross multiplication. But as there are 2 days, we can't solve it. So what we'll do is we'll find out closest multiple of 8 to 72. Closest multiple of 8 to 75. So 72 is the closest multiple and 8 into 9 is 72. That means both of them will take 92 units. Is it? No. Over here, we have 2 days is equal to 8 units. That means they will take 9 into 2 is equal to 18 days to complete 72 units. So if it's 2 days, we have to multiply 9 by 2 because it's not 1 day. So in 18 days, they will complete 72 units and there are 3 units remaining. So who will work on 19th day? So X is going to work on 19th day and X is not going to take the entire day to complete the work. So X will take 3 by 5, that is 3/5 of the day. So 3 by 5 days. Now, if Y works on day 1, Y will complete 3 units, X will complete 5 units. In 2 days, they will complete 8 units. By applying the same logic, we will get in 18 days, they will complete 72 units. Now, 3 units are still left, and Y is going to work on the 19th day. We also know that Y completes 3 units and he takes a day to complete 3 units. That means Y would take entire day to complete. Number of days required would be 19. In the option, it is 93 by 5. So if you solve 18 3 by 5, 18 3 by 5 will give you 93 by 5 days. Hence option 2 will be the answer. So whichever option is available with us, we'll go with that option. Moving to the next question. U and V can complete a job together in 30 hours. V and W can do it in 40 hours. And W and U can do it in 60 hours. In how many hours will W finish the work? In we already have the value of U plus V, that is 4 units. So we'll substitute it. And after solving this, we'll get W is equal to 0.5 units day. This is efficiency of W and not the number of days. So to find out number of days, we will simply do 120 upon 0.5, that is 240 days. So W individually will take 240 days to complete the job. It's not 240 days, it's 240 hours because all the units are in hours. Moving to the next question. A alone takes 3 days more to finish the job than A and B working together, while B alone takes 12 days more than A and B working together. How many days are required for A and B to finish the same job working together? So over here, let us assume that let both of them take X days to complete the work. Take A days more than X, we have the value of A, that is 3 days. Let B take B days more than X, we have the value of B, that is 12 days. So if total work, we assume it as 1 unit, A plus B together will do 1 by X work, and A individually will do 1 upon X plus A, B individually will do 1 upon X plus B. Now, they are working together, that means we have to add them. So 1 upon X plus A plus 1 upon X plus B is equal to X, is equal to 1 by X. After solving this, we'll get a formula that is X into A into B. So whenever you come across such questions, instead of doing all of this, you can simply make use of the formula. Now putting the values in the formula, you will get the answer. So x square is equal to 3 into 12. The value of x is equal to 6 days. So 6 days is the answer. Moving to the next question. 3 men and 5 women together a certain job in 14 days, while 2 men and 5 women together can complete the same job in 18 days. In how many days? In how many days will 9 men and 5 women complete a job thrice as big as the one mentioned above? So total work done over here would be 3m plus 5w is into 14 is equal to 2m plus 5w into 18, because they have said that they require same number of days. So as the work is same, they are working for the same job, we will have equal to sign between them. We have to find 9 men plus 5 women into what number of days will give us thrice the total work done. We have the total work done already. So you can substitute any one of the above two equations. So over here, we have substituted 3m plus 5w into 14. Now, after solving the first equation, we will get that 3 men is equal to 10 women. So if 3 men is equal to 10 women, then we'll try to convert all the men part into women part. So your main motive over here must be to get into any one variable, to convert everything into any one variable. So after doing this, so 3 men is equal to 10 women, 9 men would be equal to 30 women. We have everything in women terms, and now we can solve easily. After solving, we'll get 18 days as the answer. Moving to the next question. See, the question says two pipes M and N can fill a tank in 16 minutes and 20 minutes respectively. If both the pipes are opened simultaneously, after how much time M should be closed so that the tank is full in 10 minutes? This is a question on the similar lines, so let's solve it. Now M takes 16 minutes, N takes 20 minutes. We'll take LCM, so LCM is equal to 18 minutes. Now let us find the individual efficiencies. So efficiency of M is 5 and N is 4. We know that N is going to work for the entire time period. That means N would be working for 10 minutes, and M, we have to find out the number of minutes that it would work. How do we get N as 10 minutes? We knew this because It is given in the question that the tank is getting full in 10 minutes and we have to close one pipe. So that pipe is going to be M. Now, the work done would be n into 5 plus 10 into 4, that is equal to 80 units. And after solving this, we'll get the value of n as 8 minutes. Hence, M will work for 8 minutes. Moving to the next question. A tank has a leak at the bottom that can empty the entire tank in 4 hours. The tank is entirely full and a tap that admits 5 liters per minutes is turned on, as a result of which the tank takes 8 hours to be emptied. Find the capacity of the tank. So there's a leak, that means we have to take negative efficiency. Now, it's a leak, so the leak in 4 hours, and we have total of leak plus tank tap, that is minus 8 hours. Now we'll take LCM. So LCM is 8 liters. And now let's take the individual efficiency. So efficiency of leak is minus 2. Efficiency of leak plus tap is minus 1. Now, if we have the value of leak, we can easily find out the value of tap by substituting in the second equation. That is, leak plus tap is equal to minus 1. If we substitute leak as minus 2 in the second equation, we'll get the value of tap as 1 liter per hour. And the tap will fill the tank in 8 hours. Means 8 hours has 480 minutes. 480 minutes at 5 liters per minute, that is 480 into 5 will give us 2400 liters. Hence the capacity is 2400 liters. Thank you.